Hello friends, welcome to our channel Aha Zindagi Edu-Care. Our channel provides video lectures of maths and science from class 8 to class 12. Please visit our playlist to get the benefit of these online learning materials. Okay friends, so today we are going to discuss relations. So in this we will discuss ordered pairs, equality of ordered pairs, Cartesian product of sets. Then we will discuss number of elements in Cartesian products of sets. And after that we will discuss diagrammatic representation of Cartesian product of two sets. Okay friends. So in this will be used, concept of set will be used in this lecture. So those who have not gone through our video lectures of sets, please visit our playlist section and first go through sets chapter. After that, you will be able to understand this chapter in a better way. Okay, friends. So we will start with ordered pairs. So what is a ordered pair? Ordered pairs. See, an ordered pair consists of two elements in a given fixed order. Okay, so we can write an ordered pair consists of two elements or objects in a given order. Okay, so if A and B are any two sets, then ordered pair of elements we mean a pair. So we will write if A and B are two sets. Okay, so in order to write ordered pair, if we say A is an element of set A and B is an element of set B, so we can write an ordered pair of elements is A, B, okay, in that order only, where A is an element of A and B is an element of set B. Okay, if we change the order, it will be a different ordered pairs. If we write first B and then A, it will be a different ordered pair. So you can note that an ordered pair is not a set consisting of two elements consisting of two elements. Okay, it is not like a set in which order doesn't matter. The ordering of two elements in an ordered pair is important, and two elements need not be distinct. And two elements need not be distinct. Even if A is an ordered pair, if A is an element of A and A is also an element of B. Okay, friends? So, if we consider 2D plane in a Cartesian coordinate system, ordered pairs like 1, 2, 2, 5, 3, 7, 9, 5. This represents different points in a plane. Okay, friends. So we can write example in a 2D plane. Ordered pairs like 1, 2, 3, 5, 7, 9. Okay, represents different points in a plane. Okay. Next, we will see equality of ordered pairs. So let me clean this. Equality of ordered pairs. Okay. So two ordered pairs are equal if, or we may consider two ordered pairs A, B and C, D. Okay, are equal if A1 or A equal to C and B equal to D. Okay, that is we can write AB equal to CD if and only if A equal to C and B equal to D. Okay. See, if we consider 2 points 1, 3 and 3, 1, can we say these are equal? See, these are not equal. Even we can represent this on 2D plane, then we will get different points after representing this. Okay, friends. So these two are not equal. So A should be equal to C and B should be equal to D. Then only these two will become equal. So we will take a problem on this. Find the values of x and y. Find x and y if 3x minus 2 y plus 3 is equal to 2x minus 1 and 3. So how we can find the values of x and y? See, as these two ordered pairs are equal, so by the definition of equality of ordered pairs, we can write as 3x minus 2 y plus 3 equal to 2x minus 1 and 3. Therefore, we can write 3x minus 2 equal to 2x minus 1 and y plus 3 equal to 3. Solving these two equations, we will get 3x minus 2x, so it will be x. X is equal to 2 minus 1, so it will be 1. So x equal to 1 and y will be equal to 3 minus 3 equal to 0. Therefore, x equal to 1 and y equal to 0. This we have got by definition of equality of ordered pairs. Equality of ordered pairs. Okay. So let me clean this. Next, we will discuss Cartesian product of sets. Cartesian, this is not a problem. Okay. Cartesian product of sets. Okay. So if A and B are two non-empty sets, the set of all ordered pair AB such that A is an element of A and B is an element of B is called Cartesian product of sets A and B and is denoted by A into B. So we can write if A and B are two non-empty sets, the set of all ordered pairs AB such that A is an element of set A and B is an element of set B is called the Cartesian product of the sets A and B and is denoted as A into B. Okay, so we can write A into B will be equal to AB such that A is an element of set A and B is an element of set B. Okay, this is set builder form. Please go through set lectures if you have not idea of sets. Okay, friends. So before seeing this topic, you should be aware about sets. So if we can write A equal to 5 or B equal to 5, then we define A into B equal to 5. Okay, so we can only define A into B when these two sets are non-empty. Now we can consider an example. See, if A equal to 1, 2, 3 and B is equal to 2, 4. Okay, so what will be A into B? If we have to find A into B, we will get see all ordered pairs A, B we have to write. So what we can do, first we take an element from set A and form all ordered pairs with this element as first element and element of set B as second element. Then we can choose another element from A and corresponding to each element in B we have to form ordered pairs. So we will start with 1 in set A. So 1, 2, 1, 4. Okay. These two ordered pairs. Next we will consider 2 in set A. So 2, 2 and 2, 4. Then we will consider 3. So 3, 2 and 3, 4. Okay. So these are the ordered pairs resulting from A into B. If we do B into A, what we will get? So first we will consider first element of set B and make ordered pairs with each element of A. So 2, 1, 2, 2, 2, 3. Next will be 4, 1, 4, 2 and 4, 3. Okay. So we will get different ordered pairs when we perform A into B and B into A. Okay, friends. So if there are three sets, now we in this we have considered only two sets A and B. Next we will consider if we have three sets, then how we will do A into B into C. Cartesian product of three sets. Okay. So if A, B and C are three sets, three non-empty sets, then A into B into C is the set of all ordered triplets as here ordered three elements will be in each order in each product of three sets. Okay, so it will be a triplet as it will contain three elements, one from each. All ordered triplets having first element from A, from set A, second element from set B, and third element from set C. Okay, so A into B into C in set builder form we can write A, B, C. It is a triplet such that A is an element of set A, B is an element of set B, and C is an element of set C. Okay, friends. So we will consider. So we will perform a problem. Let A equal to 1, 2, B equal to 3, 4, and C equal to 4, 5, 6. Okay. So what will be A into B into C? So A into B into C. This we can write as A into B into C. So first we will find A into B, then we will make triplet with A into B into C. Okay. So A into B will be C. First we will consider 1. So 1, 3, 1, 4, then 2, 3, and 2, 4. Okay. We will get 4 ordered pairs from A into B, and this we have to multiply with C. So C is 4, 5, 6. So the triplet what we will get 1 into 1, 3, 4, 1, 3, 5. So first we will consider one ordered pair of A into B and make triplet with each element of set C. So 1, 3, 4, 1, 3, 5, then 1, 3, 6. Next, we will consider second ordered pair of A into B, that is 1 into 4, and we will make triplet with each element of C. So it will be 1, 4, 4, 1, 4, 5, then 1, 4, 6. Okay. Next, we will take 2, 3. So 2, 3, 4, 2, 3, 5, and 2, 3, 6. 2, 4, 4, 2, 4, 5, and 2, 4, 6. Okay. So we will get 12 elements, 12 triplets we can say. Okay. So please note that A into B into C, A into B into C. This can be either written as A into B into C, and it will also be equal to A into B into C. Okay, both will be same. So here we have three sets. If we have n sets, how we can do? So we will consider that. Let me frame this. So if A1, A2, A3, A4, and so on up to AN are n number of sets, n sets, then Cartesian product A1 into A2 into A3 and so on into AN of this n sets is the set of all n is the set of all n tuples that will depend on number of sets, how many elements will be in there, okay, of the form A1, A2, A3 and so on AN, where A1 is an element of set A1, A2 is an element of set A2, A3 is an element of set A3 and so on. And last we can write AN is an element of set AN. Okay. So we can write this A1 into A2 into A3 into and so on into AN equal to A1, A2, A3 and so on AN, such that A1 is an element of set A1, A2 is an element of set A2 and so on. AN is an element of set AN. Okay, so we can write this in set builder form. So next we will discuss number of elements in Cartesian product of two sets. So let me clean this. Number of elements in Cartesian product of two sets. See, if A and B are two non-empty sets, A and B are two non-empty finite sets, okay, then number of elements in A into B is equal to number of elements in set A into number of elements in set B. Okay, this is a theorem. It may be directly applied to the problems. Okay, we will see how we can prove this. So if set A equal to A1, A2, A3 up to let be it M, AM, and set B is equal to B1, B2, B3, and so on. Let the last element be Bn. Okay. So set A has M element and set B has N element. So we can write A into B is equal to, see, first we will take first element of set A and then form ordered pair with each element of set B, and next we will do with second element of set A and all the elements of set B and so on. Okay, so this we can write A1 B1, then A1 B2, A1 B3, and so on. Last order pair with A1 will be A1 Bn. Okay. Next we will take A2. So A2 B1, A2 B2, A3 B3, and so on. Last order pair with A2 will be A2, this is A2 B3, A2 Bn. Okay. So we get ordered pairs like this, and with last element of set A, ordered pair will be AMB1, next will be AMB2, AMB3, and so on, and last ordered pair will be AMAN. Okay, so these are the ordered pairs. So if we see, it is in the tabular form and there are m number of rows. Okay, A1, A2 we can see m number. If we see this, m rows and n columns. Okay, so clearly we can see from this, A into B has m into n ordered pairs. Okay, order, I will write this ordered pairs. So we can write n of A into B equal to n mn, and it will be equal to na into nb. Okay, so if there were three sets, so you can note first one, if A, B, C are three finite sets, then n of A into B into C will be equal to Na into Nb into Nc. Okay. Second one, if either A or B is infinite, is an infinite set, then A into B is also an infinite set. Okay. So we have seen how to calculate the number of elements in Cartesian product of two sets. Next we will move to Graphical representation of Cartesian product of sets. So, if we consider two sets A and B, which are non-empty sets, and if we represent A into B graphically, how we can do this? See in this, so we will first consider A and B are two non-empty sets. Okay. So in order to represent this A into B, so A into B, we have to represent graphically. So what we will do, we will make two lines, one horizontal and other line is vertical. Then we will represent all the elements of set A on the horizontal line. Suppose A is equal to A1, A2, A3. Okay, and B is given as B1 and B2. So two elements of B and A has three elements. So we will represent A on elements of A on horizontal line. So let it be A1, A2 and A3. Okay. Next we have to represent elements of set B on vertical line. Let it be B1 and B2. So in order to represent the ordered pairs, what we will do, we will make dotted lines for each element like this for set B and this is B2. Okay. Next, for all the elements of set A, we will also make dotted lines perpendicular to horizontal line. Okay, like this should be straight only. And then next is A3. So what we get if we see this point, okay, we will get 6 points, and also by definition of number of elements, as A has three elements, n A equal to 3 and n B equal to 2. So n of A into B will be equal to 3 into 2 equal to 6. So by representing it graphically also, we are getting 6 ordered pairs. So this one will be A1 B1, this is A2 B1, and this one is A3 B1. This one will be A3 B2. This one will be A2 B2 and A1 B2. Okay. So six ordered pairs we are getting, and if we do by simply multiplying A and B, so A into B, we can see we will get A1 B1, A1 B2. Okay. Next we will get A2 B1 and A2 B2. With third element in A, we will get A3 B1 and A3 B2. Okay friends, so we are getting all these elements of A into B, and if we check by graphical representation, we will also get same point. See, A1 B1 is this one, A1 B2 here, A2 B1 this point, A2 B2 is this point. Then A3 B1 is this ordered pair, A3 B2 is this ordered pair. Okay, so this is how we can represent on a graph all the ordered pairs or Cartesian product of sets. Okay friends, next we will see how to represent Cartesian product of two sets by using Venn diagram. Diagrammatic representation of Cartesian product of two sets. Okay, so if A and B are two sets, if A and B are two non-empty sets, then we can represent let set A B A1 A2 A3 and set B is equal to B1 B2. So we can draw Venn diagrams representing set A and B. Okay, so if this is set A, A1, A2 and A3. Next, set B, Venn diagram of set B, we have to draw opposite to set A. So we will draw here. Let it be B1, B2. Okay, this is our set A, this is set B. Next, we have to draw line segment starting from each element of set A and terminating to each element of set B. So ordered pairs if we see A1, P1, okay, and from A1 and B2. So with A1 we will get two ordered pairs, that is A1 B1 and A1 B2. Next we will consider A2 and then we will go, it will start from A2 and go to set B elements. Okay, terminate at set B elements. Again with A3 we will get A3 B1, next A3 B2. Okay, so this diagram represents A into B. Okay friends, so next we will solve problems on what we have discussed. So let me first clean this. First problem you may write, this is on equality of ordered pairs. Find A and B if A plus 3 and comma 5 equal to 6 and 2a plus b. So by definition of equality of ordered pairs, from a plus 3 5 equal to 6 2a plus b, okay, as these ordered pairs are equal, so corresponding element shall be equal. Therefore, a plus 3 equal to 6 and 5 equal to 2a plus b. So from here we will get a equal to 6 minus 3 equal to 3, and b, from this one we will get 5 equal to 2a plus b, as we have calculated a, so a is 3 plus b, and from this we can get b equal to 5 minus 6 equal to minus 1. Therefore a equal to 3 and b equal to minus 1. Okay friends. So next we will discuss, if ordered pairs are given and we have to find the set A and B. Okay. So we may consider this problem. Suppose A into B is given as, or if A into B equal to A1, A comma 1. Second order pair is B comma 3, A comma 3, B1, A2 and B2. Okay. So we have to find A and B. See how we will solve this. Since A into B is given, so we can conclude that all the first component in the ordered pair are from set A, and second component in the ordered pair is from set B. So A is set of all first component first component of ordered pair in A into B, and set B is set of all second component of ordered pairs in A into B. Okay, so we can write set A equal to A, B, okay, A and B. So these two are an only element. Next, set B, we can write set B equal to 1, 2, 3. Okay, friends. So this is how we can find two sets if product of Cartesian product of two sets is given. So we will discuss another problem. Let me clean this. This is based on graphical representation of A into B. So write down, let set A equal to -1, 3, 4. These three elements are from set A, and set B has elements as 2 and 3. So we have to represent A into B, represent A into B graphically. Okay. So how we will represent this? See, as discussed, we have to draw two lines perpendicular to each other, one horizontal and other vertical lines. On horizontal line, we will consider first set. If A into B we have to find, then we will represent A on horizontal line and B on vertical line. But if we have to find B into A, then we need to represent set B elements on horizontal line and set A elements on vertical lines. So here we have to find A into B. So we will represent on horizontal lines. Okay. See, first element is minus 1. So minus 1 will lie this side, minus 1. It will be 0. Okay, 0 is here intersecting point. Then 3 will lie somewhere here. It is not to the scale. And 4. Next, we have to represent elements of set B on vertical line. So this is 2 and it is 3. After that, as discussed, we have to draw dotted lines on all the elements. Okay, so we will draw like this. And also we will draw at 2 and 3 for set B elements. Okay, so we will get these 6 ordered pairs as set A has 3 elements and set B has 2 elements. So by product also 3 into 2 we will get 6. So this one is minus 1 2 minus 1 3. This is 3 3 and 3 2. This one will be 4 2 and this one is 4 3. Okay friends. So this is how we represent Cartesian product of two sets graphically. So we will solve another problem. Next, if set A if set A is equal to 1, 3 and 5, set B is equal to x, y. Okay. Then we have to represent by arrow diagram using Venn diagrams. So represent following by arrow diagrams. Okay. First one is A into B. Second one is A into A. Okay. In Cartesian product, the two sets we may consider same also. So A into B. So what we have to draw? We will first draw set A, then set B. A and B. Okay. Elements of A are 1, 3, 5 and B is x, y. So considering first element, we will form all the ordered pairs with elements of set B. So like this, arrow starts from element of set A and terminate to elements of set B. Next, we'll consider 3. So this 2 and this with 5. Okay. So these 6 ordered pairs we will get, and what will be if ordered pairs we write A into B is equal to, see first one 1x 1y, then with 3 3x 3y, then with 5 5 comma x and 5 comma y. So 6 elements we are getting. Next we will draw set A and again set A into A. So 1 3 5. Next one is set A only, 1 3 5. So we will join arrow like this. So with 1 we will get 3 ordered pairs, then with 3 also we will get 3 ordered pairs, and similarly with 5. Okay, so we are getting 9 ordered pairs. And what will be elements, what will be ordered pairs of A into B? So we can write 1 1 1 3 1 5. Okay, next with 3 3 1 3 3 3 5, and with 5 5 1 5 3 and 5 5. Okay, so this is our A into B. So this is how we solve problems related to graphical and diagrammatical representation of Cartesian product. Okay friends. So today we have discussed ordered pairs, equality of ordered pairs, Cartesian product of two sets and three sets, graphical representation and diagrammatic representation of Cartesian product of two sets. I hope all of you have understood. If you have any doubt or any query regarding this topic, please let me know in the comment box. And if you have seen the whole video and liked it, please like the video and subscribe our channel Aha Jindagi Edu-Care. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.